Hello again. We're going to talk in this video about signal paths and the digital audio conversion process. And this discussion involves three different uh, energy realms, really. We have the acoustic realm, which is happening in the world all around us. Our ears work in the acoustic realm. Uh, Musical instruments, traditional music instruments, are acoustic oriented creators of sound. And in class, we often take a moment and talk about the technology associated with acoustic instruments and ask them to describe the process of creating sound on their acoustic instruments or on a acoustic instruments. For instance, with a piano, there is a moment where you choose to strike a key. You press your key on the keyboard. That enacts a process that results in a sound happening. So you press the lever of the key enacts the hammer to move backwards and then smack against those three strings that are strung against the soundboard. And so there's a passage of energy from that hammer to the strings. The strings vibrate. The vibrating strings inside of a piano resonate against the soundboard. And depending on the model of instrument or what have you, how it has a certain kind of resonance that happens inside of the wooden piano. That resonant sound is then sent out of the piano into the space that it is in, and then someone in that space, presumably the person playing the piano, is hearing the immediate feedback from that piano, exciting the air molecules around it, and those are being picked up by the ear. The ear then is sensing those wave shapes in the air molecules around it, and then sending impulses to your brain, and your brain is like, that's a piano sound. There is a process to that is important to acknowledge. It helps to set up the process that is associated with any of these other realms, whether it's analog electrical audio or digital audio. So talking about that acoustic process is extremely important to me in my classes. I think it's a great way for students to wrap their mind around the digitization of audio eventually. So our talk about signal paths starts with acoustic energy, then goes to analog electrical energy, and then into the digital realm. Those are three very different energy realms, and there's a conversion process that happens between each one of them. So for instance, in this situation I am speaking, I'm creating acoustic energy. This microphone is an analog electrical microphone, and it is converting my acoustic energy phenomena into an electrical signal that is passing into this cable. And this cable is carrying electrical signal into the preamp in my interface, which is over there. And I can't, if I moved it, I would ruin everything that's happening right now. So there's an audio interface over there that is accepting this microphone signal that is electric. That electrical signal is then being converted into data. There is a digital audio converter inside my interface here so that you can hear it, so that can be converted into an audio signal that can be used on a computer. Computers can only understand data. So that's the process of understanding those three realms. We're stepping from acoustic to analog to digital. And when you hear my voice, you are hearing that digital audio signal, that file, being played and converted by the computer to an analog electrical signal that is going through your headphone cable and into the speakers of your computer or your headphones or whatever you're listening to this on. And those are then converting again to acoustic phenomena. So this playback is going from digital to analog to acoustic. So it goes back and forth between those two realms. Let me switch over to the slides now, and we'll talk through a little bit of this process. So as I said, we're basically stepping from acoustic to electrical and then electrical to data. Those three energy realms. Acoustic energy, just to review, are vibrations transmitted through the air. And these sounds are transmitted through the air around us. Our ears are there to adjust and to, become barometers, right? It detects those changes in air pressure. And these vibrations are continuous flow. And I mention this because when we go into analog electrical energy, it's also a continuous flow. These air molecules are constantly moving around us in a very natural, flowing way. Positive and negative amounts of change in air pressure are happening all around us. The electrical realm is analogous to that acoustic phenomena. So electrical energy is energy that is a result of the flow of electric charge through a conductor. It's almost like water through a pipe. If you might hear some electricians or electric people talk about electricity being like water through a pipe, that there is a flow, a positive and negative charge. Electrical energy is often passed through a wire. A wire is your conductor. These vibrations are continuous flow of positive and negative amounts of electrical charge. And so that electrical signal is a model of the acoustic realm. And so that's where we get the word analog. It is analogous to the acoustic realm that we live in. So we need transducers to convert from acoustic to electrical energy. Transducers convert. They are converters, and they help us to change from one realm to the next. Microphones convert from acoustic to electrical energy. Speakers are the opposite. They convert from electrical to acoustic energy. Input transducers are very important. Your microphones are input transducers. They convert acoustic sound to electrical energy. Other examples are turntable cartridges, instrument pickups, anything that takes vibrations and converts them into electrical signal. Piezo transducers are little discs that you can stick on things too. Sometimes instrument tuners have little clamps that you put on, for instance, a violin. You can clamp a transducer onto the bridge so that you can send it as an electrical signal into the tuner. Those are input transducers, and they're converting from acoustic vibrations into an electrical signal. The other way is through the output transducer. Your output transducer converts electrical signal to acoustic sound, and that is most often a speaker. You can sometimes you'll see experiments in turning a metal plate into an output transducer. And I don't know if you've seen the videos of people sprinkling dust onto the metal plates and playing a tone, and it turns into a design. The plate is a output transducer because it's taking a signal and it's vibrating according to that signal. So microphones and speakers are generally opposites of the same system. And our signal path uses an analog signal path uses continuous vibrations that are a model or analogous to the original sound waves. So an original sound wave goes into the microphone, our system amplifies it and makes it louder, and then goes to a loudspeaker, which then recreates that signal at a higher volume. In this case, there is no digital conversion. This is simply a microphone to amplifier to speaker. And therefore, we get this flow chart, which helps us understand an analog audio system, or even a digital one, because it shows us that conversion from input from microphone, the mic level signal, which is really small, to a preamp. The preamp sends out a line level signal. That line level signal goes to a power amp, which goes to a speaker. Notice that these three signal levels, mic, line, and speaker, are different. Meaning that if you plug a line level signal into a preamp, you're going against this model's flow, and therefore you could damage equipment. Like a CD player plugged into a preamp is too hot of a signal, and you might damage the preamp. Similarly, if you plug a microphone directly into a loudspeaker or a power amplifier, you will never hear it because it's extremely small. And if you do crank it up, if you crank up this power amplifier and you get this little tiny sound out of your microphone, it's because you have a mismatch of signal, and you're going to introduce a lot of noise, and it's not going to sound good. So knowing the output level of your gear helps to navigate this analog system. And this flowchart is, I often ask students to memorize and recreate this on exams. It's a really, really, really useful mental tool, I think, for navigating any audio system. The digital realm is simply a way for computers to interact with electrical energy. Because electrical energy is continuous flow, it is not, your computer cannot understand any gray area. It's either on or off. It's either 1 or 0. Computers are quite, contrary to like how we understand computers, they're very useful. We use them all the time, smartphones, etc., tablets. But computers are extremely simple and require a 1 or a 0 at every point. Everything must be measured and encoded. Computers are objective. They cannot understand a continuous signal, either electrical or acoustic. And so computers must encode or measure, or something must encode or measure a continuous signal and assign it a numerical value. This numerical value becomes data. That data is sent as bits and bytes, and in classes, we don't have to go down this rabbit hole, but in classes we talk about what a bit is and a byte is, and how many bits are in a byte, and what storage means, and the need for storage, or the need for computing power, and how that relates to audio quality. And when we talk about digital audio, we also need to talk about storage and how we manage our files, because that digital that acoustical electrical signal is measured to create a data stream, and that data stream is either streamed or saved by your computer. In the realm of digital audio, this measurement process is called sampling. Any sort of physical entity like sight, sound, those things are often encoded by a computer so you can read it. These images you see on this video are also encoded and digitized into a file. In this example, you can see how an image is pixelated and digitized, or a book is digitized, or the audio signal is no different. So the amount of sampling that is done on an incoming waveform determines its fidelity, how lifelike it'll be. We also since we've talked about storage and data management, we can talk now about how if you sample something a lot, you get a really great audio file, but you also have a really big audio file. The more samples you make, the more data points you have, and the more data points you have, the bigger your audio file. So there's a balance that we must strike to create digital audio files that are manageable, especially those that are intended to be streamed or downloaded. So that conversion, and that's a whole other can of worms, and that may be talked about it in the future. So analog to digital conversion, ADC, is an important process that converts a continuous analog signal into a data stream that your computer can understand. It is a really important part of any digital audio signal path. And in these days, almost everything involves this conversion. ADC is a part of our smartphones. ADC is a part of, TV audio, video game audio, everything. The other way, digital to analog conversion, is to get audio out of the computer from digital to analog. It converts a data stream into a continuous analog audio signal. And this is a part of any digital audio signal path. And so whereas before we had this analog audio system model, we can now look at it in a digital realm. And notice how these elements are still in this flow. Digital audio recording involves an input transducer and a preamp as before. Those are all analog. But there is a point at which your computer must convert from analog to digital for it to be sent to a computer. So this, I also asked them to learn and memorize this flowchart as well. We have an input transducer, a microphone that is connected to a preamp. That preamp is then sent to an ADC, which stands for analog to digital converter. and that is sampling your incoming audio signal and sending that data stream to your computer. These circles show the change in realm from electric to digital, electric analog to digital. When you hit play on your Laserdisc or CD player or whatever digital media you're using, MP3, YouTube, you are enacting this process in reverse. Your computer, your smartphone, or whatever you're using, digital recorder, what have you, is taking that file, and that file is sent to a digital to analog converter. That digital analog converter is sending then an electrical signal to your amplifier, which then goes to your speaker. And so this realm is your digital realm that is then going to your electrical analog realm. Once it hits the speaker is then also converting it to the acoustic realm so that we can hear it because of our ears. We can hear it, and others can hear it too. So I hope that is a clear sort of discussion of these three audio realms. Typically, we spend a few weeks on this in a class. This is a condensed sort of discussion about this. And it's important to keep this in mind as we work on projects, talk about digital audio editing and recording.